In this program, you'll blink an LED on and off. However, the code is going to decide how long that delay lasts with the LED on and with the LED off. Within the void setup function, you'll use the pin mode function with the arguments to and output to set port 2 as an output and plug an LED in there. The void loop may look familiar if you've done some blinks before. The first function is a digital write function with the arguments to and high, so it turns on port 2 and turns on the LED light. You've seen the delay function before, but usually we give the delay function one argument, a number measured in milliseconds, that determines how long the program pauses at that point. In this program, we're replacing that number with a function, the random function. The random function itself has two arguments. The first argument is the lowest possible random value that you want to select from. I chose 10 milliseconds here. The second argument is the highest possible random value that you want to select from. I chose 2000. So you can think about this bit of code, random, open parentheses, number, comma, number, close parentheses. That whole bit of code is replacing a number like 100. When this line of code runs, the program is going to run the random function, which selects between the low and high number and uses that number in the code. The next line is a digital write function with arguments to and low. So after that random delay between 10 and 2000 milliseconds, the LED will turn off, and then we'll have another delay that uses the random function instead of a number to select a brand new random number. And that delay is how long the LED will be off before the code reaches the closing curly brace of the void loop, jumps back up, and turns the LED on again. So let's imagine this code running through a few times so we can see what might happen. First, you'll turn on the LED, and then the random function will select a number between 10 and 2000. Let's say it selects 100. The LED will be on for 100 milliseconds, or 0.1 seconds, and then the digital write to low function will run, turning off the LED. Next, you have a delay with the random, and let's say this time it selects 1500. Now you'll have a delay of 1500 milliseconds, or 1.5 seconds, with the LED off. After that delay is completed, the code hits the bottom of the void loop, jumps back up, and turns the LED on. The next time this delay random runs, the delay could be something totally different, like 10. So now the LED is only going to be on for 10 milliseconds, or 0.01 seconds, before this digital write function turns the LED off, and this random function decides how long the LED is off. It could be that this is 20 milliseconds. So this void loop, the second time through, would run much faster than the first time through. And because every time random runs, it selects a new number, you're going to have void loops that may never be the same as the one before it. In a way, using the random function allows your program to make a decision, whereas before you always had to define exactly how long your delays were.